Hey, and welcome back to Buildsum. And this is going to be a little bit of a series on calculating wall bracing, continuing on from my previous series on AS 1684.2, the timber framing code for non-cyclonic areas. We're just going to look more specifically at wall bracing and how you calculate and work that out. Okay, so obviously this is comes from AS 1684.2. The timber framing code, non-cyclonic. It's section 8, which is racking and shear forces, bracing. Okay, so the first paragraph says that bracing has to be designed and provided for each story of the house and the subfloor where required. So if you have a 2-story house, you have to design the bottom floor and the second floor independently of each other. There's different requirements because of there's the second floor. It's got more wind exposure, etc. And also, if you've got a subfloor, if the house is up on piers, you have to design for that as well. Also, as the wind can blow from any direction, the wind direction that results in the greatest loading shall be used. So basically, the side of the house that presents the largest surface area facing the wind, we use that in our calculations. We always calculate 2 directions anyway. So one blowing onto the front of the house and one blowing onto the side of the house. Now, if for some reason the front of your house doesn't have much surface area and there's more surface area at the back, then we would use the back. That's our biggest area and will give us our biggest load. So we always go with the largest surface area to work out our loads. Just a note about temporary bracing. Temporary bracing is required to support wind and construction loads on the building during construction. Temporary bracing shall be the equivalent to at least 60% of the permanent bracing required. It's not something I really thought about when I was erecting wall frames and that sort of stuff, but they say 60% temporary bracing. And if you do install temporary bracing and you want to leave it in place, it can then become part of the permanent bracing. Okay. So what the things we're going to look at in this series of videos, firstly is the wind classification, which we'll look at in this video, and then in subsequent videos we'll look at determining the wind pressure, determining or working out the area of elevation, calculating the racking force on the building, designing bracing systems for the subfloor and for the walls, checking that we've got even distribution and spacing of our bracing. There's no point having all our braces on one end of the building and the other end's got nothing in it. And we then can check the connection of our bracing to the roof and ceilings and floors, because there's no point the walls being braced if they're not bolted or connected to our floor and connected into our roof system. So to determine the wind classification, the wind classification or the designed gust wind speed should take into account the building height, the terrain category, the topographic classification, and the shielding classification. Now, there's heaps of regulatory authorities, your council and your private certifiers. They may provide you with information. They could give you a map to work it out, or you can get them off a lot of websites. A lot of shed building companies have those for general information, and I'll put a link in the description shortly for one of those so you can have a look. Or, as I said, your council or your private certifier, they may just give you a wind classification for your area. For Sydney, I generally work on an N3, which is getting up there. It's one of the higher ones for Sydney. That's just my go-to wind speed, unless on investigation I find out that I need to get an N4. Alright, so you can work that out, or your private certifier or council can give it to you. There's a link. I'll put that in the description so you can have a look at that document in your own time. And that's just there. That's the link. As I said, I'll put that into the description. That gives you a lot more detail and shows you how to work out the wind classification for your own area. So once we have the wind classification, We then need to work out what pressure that is going to put on our wall, which then we can work out how much bracing we need. So in the next video, I'm going to look at wind pressure.
G'day, I'm back. Just to let you know that if you like this video, you can subscribe to my YouTube channel, or you can follow me on Facebook so you don't miss out on more great videos.